So let's suppose we want to find the height of something. So let's just do a boring flagpole, shall we? You can pretend it's something else. Okay, who wants to be trying to find the height of this flagpole? Who wants to volunteer? Candace?
Yes, Candace, let's go.
Okay. So here's Candace over here dancing. And she decides to stop from her dancing for a moment and measure the angle of elevation. And normally we would take this height into account. I don't think you need to worry about that. So, what angle do you want to be looking at the flagpole? 70? That's way up. Okay. So my picture isn't drawn to scale, obviously. Candace, who do you want to be on the other side of the flagpole dancing? My mom. Okay. Candace's mom is over here dancing. And she looks up at the flagpole and finds the angle. What angle is she looking at the flagpole at? What? 50 degrees? Okay. Candace, how much distance is between you and your mom?
12 feet. No, you gotta mathematically figure it out. That's a really tall.
No, I need this number.
1 feet. 120. Are you kidding? We're just
Okay, let me figure out a good estimate. I don't know, 20 feet? I don't know.
20 feet. That's a really tall one.
No, it's not, because if you think, this is not drawn to scale. This is a 70-degree angle, so it should be more like there.
But drawn to scale, yes.
Honestly, the flagpole here is about 30 feet tall. Okay. I don't know what this one's going to turn out to be. I don't know, because Candace made up the problem. So, all right. Here we go. How do we find the height?
Well, we have two angles. 180 equals the height, so we have all the angles.
Mm-hmm. Oh, we know this angle up here?
Well, we can figure it out.
Okay, how would we figure it out?
Left side. So it's 90 on that side. You find out the side and plus them together. So.
Okay, wait, I'm going with finding this angle.
That's 20.
Okay, these are 90, yeah.
Wait, the big one or the two?
These are 90 degrees.
Yeah, find
But what about the whole big angle? Because the whole big triangle, because the issue here is we don't know what this piece is, or this piece, or this piece, or this piece. So working with just one of the right triangles to find the height,
60?
that's not really going to work very well right now, right? So 70 plus 50 is what, 120? So the angle up at the top would be 60. Okay, so this angle up here is 60 degrees, and we know that the side across from that angle is 20. What could we do? Would we be able to use SOHCAHTOA or law of sines if we found like this side and this side? Would that help us to find the height? So if we know that angle and we know this side, is it possible to use another angle to find another side? Which one do you want to do? Let's call this one heart. Let's call this one smiley face. Which one do you want to find? Well, we only need to find one of them, honestly. Go with heart. Okay, so if we're finding heart, then we are using which angle? 50, because it's across from heart. Good. So to do law of sines, we would do sine of 120 over 20 equals sine of heart. Well, you don't think alpha, beta, gamma, those are weird variables? I think they're kind of weird. Oh, oops, yes. Thank you. I'm so glad you're keeping me in check. Sine of 60 over 20 equals sine of, 50. My gosh, I need to go back to bed. Over heart. There we go. So now how do we solve for length heart?
20 sine 50 divided by sine 60.
So heart is going to be equal to 20 sine 50 divides sine 60. Okay, so what does that give us for length heart? 17.2. Now, caution, because there's typically rounding errors when you use a rounded answer, what do you probably want to do with this answer? Give as many decimals as you feel like you can handle. So, 17 point what? 2156. Okay, that's probably good. All right, now that we know that this is 17.2156, and we want to find height, there's two ways we can do this problem. We can either use a SOHCAHTOA method, or because it's a right triangle, or we could again use a law of sines method. Law of sines would just mean you're doing sine of 90 over 17.2156 and sine of 70 over h, right? So, here, let's just write that down. So law of sines could be done by doing sine of 90 over 17.2156 and then sine of 70 over h to find the height, right? Or we could use SOHCAHTOA, and we could do, we want to find h, which is opposite the 70, and we have the hypotenuse, which is 17.21. So which ratio would use opposite and hypotenuse? Sine. Sine of 70 would equal opposite h over hypotenuse 17.2156. So then to find the height, all you'd have to do is go 17.2156 times the sine of 70 and calculate that height of our flagpole. What do we get? Okay, say it again. 13.3. Okay, you know what? I'm cool.